So everyone, yeah, welcome to Practical Unit Testing in LabVIEW. Let's go do this to me, is it? Good work, off to a good start. Here we go. Okay, so yeah, my name's Percy. I've been using LabVIEW for over 25 years. I remember before it had undo, that was a ways ago. LabVIEW champion, certified LabVIEW architect. I worked at a company called CPU Systems down in Melbourne for nearly 18 years, and I've been freelance since then for about 12. I studied electronics at uni, but I fell into doing programming almost immediately after that. Mostly I write LabVIEW code. I've also worked in C and C++, some Ruby and other web stuff, a bit of SQL. So I have an interest in the wider software world outside of LabVIEW as well. Our giant's a female. This is Professor Michelle Simmons. She's a quantum physicist, originally from the UK. She moved to Australia in 1999. She actually came from the Cavendish Laboratory at Cambridge. She started at University of New South Wales, mostly because of their early success in using silicon as the basis for quantum computing devices. She's led teams that helped develop the first functioning single atom transistor, the thinnest conducting wire in silicon, which is only 4 atoms wide and 1 high, but has the same conductivity as copper, and the first 2-qubit gate. So she's a pioneer of quantum computing. She is a founding member and director of the ARC Centre for Excellence in Quantum Computation and Communication Technology. She was Australian of the Year in 2018, has an Order of Australia, and also is a Royal Society Fellow. So what is the point of unit testing, you might wonder? So unit testing doesn't seem to be as widely used in LabVIEW as it is in other programming languages, which is odd because many of us write software that tests things for a living, whether it's in production or in a lab environment. So you'd think we would understand the purpose and utility of testing things before it goes out to a customer to gain confidence that it's going to work as expected. So the same thing really applies to the software that we write. Just as an aside, I'd be interested to know if anyone actually does do unit testing at the moment. But okay, more than I thought. That's very good. There's some sort of kinda. So people who don't, I'd be interested to know if it was because you tried it and stopped, or if you've just never tried it. Maybe chuck that in the Discord if you've got thoughts about why you do or don't. So what do we hope that unit testing will give us? Obviously, the first most obvious thing from testing is reduce bugs. Integration should go more smoothly because of that. So fewer bugs to start with, integration should be easy. Improve code quality. So the act of actually writing your code so that it is testable helps separate and decouple modules, which goes a long way to improving the quality. Shorter overall project time, ideally. So how that works is we want to move basically effort from integration testing back into the coding sort of phase. So you do coding testing, and hopefully less integration testing after that. And then final acceptance testing. So yeah, bugs obviously get more expensive the later you find them. So ideally you want to try and surface them as early as you can. And also importantly, it's not just testing, it's automated testing. So that saves you effort as well. So by the time you've run a test manually a couple of times, you may as well have automated it. You'll save yourself effort. So what is a unit test? A unit test tests a unit of code in isolation. So a unit is a collection of VIs with a common function. It could be a class, a library, just a group of VIs. Most importantly, it has a well-defined API of some kind, so that there's a clear boundary between code that the public talks to and code that's inside of the object that you're not supposed to fiddle with. So, sorry, my mouse pointer's decided to be a mouse. There we go. Okay, so yes, so the API should clearly delineate what code is outside and what code is inside. So ideally the API shouldn't change very often, if at all, but the code that's inside that isn't exposed to anyone, you can freely change and refactor as you need to. So you should, and the code also should be independent of other parts of the application. So you should be able to take your code module and test it without requiring hardware or anything else, like files and databases and things that you maybe would rely on. So you should be able to check your code out on your laptop at home and run the test successfully without anything else. So just to clarify, not dependent doesn't mean that you don't use other parts of the application. It means that they're not statically linked inside of the object, so you can pass them in by dependency injection, which is just a fancy way really of saying that you're passing them in as an argument, but the thought process behind why you're doing it is the important part. So unit test code in isolation, using simple and easy to understand tests. So you should be able to look at the unit testing code and see very clearly what it is that it's doing. It should be obvious just by inspection. So you shouldn't need to test your tests to prove that they're correct. You should only be testing one aspect of the behavior at a time for each test. They should be repeatable, so the test doesn't depend on any state outside of what it sets up itself in the module. They should be reliable, which means that the only reason a test should fail is because there's something wrong with the code under test, not anything else. And they need to be fast, which is perhaps not obvious, because you will end up with quite a lot of test cases typically for a given module, so you need to be able to run them quickly, because the speed at which you can write some code, test it, make sure everything's good, write some more code is a key part of making the unit test cycle work. And also, if you're running your tests frequently and you do break something, you should have a pretty good idea of what it is that caused it to break, because you probably just touched it. So all the context for that is still in your head and you should be able to fix it pretty quickly. So the takeaway from that is test early, test often. So this is what a unit test looks like. This is JKI's VI tester. It's what's called an XUnit style unit testing framework. So it's based on Smalltalk's SUnit framework from 1989. So it's a pretty common way of attacking unit tests. So the left-hand window has setup, so every test gets that code executed first. So anything that's common to all of the tests will happen in there. In this case, we're setting up a report path and some test data. Then in the center section is an example test. So that's grabbing the path and test data, creating a report, dumping it out to file. And then in order to actually test that, you have to read the file back in again and check the contents. Then in this last, the VI with a tick on it at the end here is the actual test part. So that's asserting that this string from the file is equal to the expected string. And then during the tidy up at the end is just deleting the temporary file that's been created. So this is fine as far as it goes. It could actually be improved a little bit, I think. That's gone too far. Did I skip? I did skip a file. There we go. Sorry. So yeah, so this is almost the same, except now that the VI under test is now, rather than writing out to the disk, is now just generating a string. So you can still write that out to file, but now that's a little more flexible. If you need to do something else with the report string, you can send it off to a database or off over the network or something like that. A purist would argue that the report generation module shouldn't even need to know that a file system exists, because it's not its job to write things to disk. I would probably still tend to include a VI for doing that, just because it's more convenient to have it tied together. And short that, you're going to have to write the code to do the writing to disk whenever you call this anyway, so it's probably easier still to keep it in the module. So this is, we'll start off with JKI's. So yeah, VI Tester is an open source framework. It has a BSD license. You can find it in VI Package Manager. Most of these tools you can. It's not as actively supported as it used to be now, unfortunately. It's still probably one of the most widely used tools though. There's a lot of community support for it in the way of tutorials and add-ons and things of the like. So you'll notice it has a class here. This is how the tests are configured. So you don't actually need to know very much about object-oriented code to use this though, even though it is class-based. Really, the only thing you need to know is that in the control here is the data that gets passed between setup into tests and then back out again. So in this case, this is an XML string, because this is an XML string parsing class that's being tested. And all of these tests are member methods. You don't even need to know about classes to add new ones though. There's a template VI here that you just create a new instance from. So it is object-oriented, but you don't really need to know very much about it at all to be able to use it. This is the UI in a second. So you'll notice all of the tests here start with the word test. So any methods in here that don't start with test, say I'm not a test for instance, is not shown in the test list. Run these real fast. So it will take a little bit longer the first time it's executed to run. It should be on the order of about 10 seconds or thereabouts. They're pretty close. So if we run it again, it'll only be a couple. So you'll notice there's two separate classes being tested here. There's a XML stick parser test case and a PCDS3 one. They are very similar. I'll have a quick look at one of these first. So these ones that all pass are testing a single value at a time. So this is our XML string that was in the setup phase. This is our software under test, and that's the value that it spits out of a cluster, and then the expected value for that. show you a floating point one. Very similar, except that there's a tolerance value that's passed in. So each of these, so this VI that's under test spits out a cluster, but each one of the elements is tested separately. There's two reasons for that. One is a stylistic choice, that generally you want to test one thing at a time, so if something fails, you know exactly which member it is that's the problem. And also, as you'll see here in this second case, that if you're doing direct cluster comparisons of all of the cluster data against an expected cluster, it just says the data is different, which is not super helpful as a message if you're trying to work out why it's failed. And it goes further than that. So I've put in x equals y here, just some, are these two clusters the same? You'll see there's a couple of values that are different, but they're different by only a tiny amount. So normally you would put in a tolerance for that, but you can't actually put tolerances in when you're comparing clusters against each other in this tool. So that's out the window. So even if you had a cluster that was all floating point values, or an array even of floating point values, you still can't use the tolerance value. It only works for single values at a time. So you're sort of stuck with doing them one at a time anyway. And that's also, I think, the preferred way of attacking it anyway. The VI tester. So I'm going to zoom through these super fast just because it would take ages to go into them in any sort of depth. I do have a post on my website which goes through most of these except for one of them, which is new. So unit testing framework, this is the first party unit testing framework from NI. It's quite a different beast. As you can see, there's no classes or anything here. It's just an LV test file, which defines the test. That's for completeness. Well, this does fill a niche that I don't think any other tools actually do. Because NI has a ISO 9001 certification, you can use this for medical devices and defense and things like that that require quality standard traceability. I don't think any other tools could throw open source have anything like that. So if you are doing unit tests for code that's used in those sort of industries, you probably need to use this anyway, regardless. I don't think it's because NI has an ISO quality certification, okay. And for traceability, that you want to use a tool that's written by a company that has a traceability thing, then your code is traced back to a tool that's governed by a quality certification, meaning that they followed a particular software process in the development of it, and they can go and be audited to prove that their process is good, basically, or at least documented. So it doesn't even need to be good, really, to be certified, but as long as it's documented.
Basically, it goes back to who's going to test it.
Yeah. So it's just a chain of responsibility of sorts. So yeah, so because of that, yes, the other useful feature of this that is probably not anywhere else that has a requirements ID, which links back into requirements gateway, which is another NI tool, which is probably relevant for large scale development more so than smaller stuff, but that can also be useful. So in the test case, we just have, I should actually say here, the actual VI to test is specified in this first configuration tab as well. Most of the setup is done in here, so you can see a picture of the VI under test. We have our packet in, which is our main input. And see in here, that's got an XML string in it, same as what we were doing with VI tester, and stick as the cluster of interest that we were having a look at.
I call that wire.
Sorry, what was it?
I call that wiring my text.
Okay.
Because your wires are of the
All right, so yeah, this is the cluster we're having a look here, and you'll have a look and see that all of the expected values are in a single place in this one. So again, you can hit the entire cluster in one go using this. But because it has, this mouse moving over here is throwing me off. We have a precision setting over here, so we can actually set up floating point values to have a particular tolerance, have that work. So one thing to know about unit test framework is that it does not play nice with classes at all. You can put class methods in here, but the class, when it shows up in here, is just like a placeholder, and you can't actually modify it or put data into it or do anything like that. So you'll need to use a setup and teardown VI to actually set up the state of your class before you test it. And it's even worse with dynamically, what are they called? Dynamic dispatch. Thank you. Dynamic dispatch VIs, you actually have to wrap those in a static wrapper before you can call them as well, because it won't even talk to dynamic ones. So that's uphill both ways in the snow if you're going to try and do that. It does have test vectors, which are quite nice. So I'll actually open up a different test for that. So what that does is if you have a VI under test that has a couple of different inputs and you want to test every single possible permutation of inputs to that, you can set up a single test that will actually go through, set up vectors for each input, and then it'll go through them in order and spit out the results and then check them against a results array, which you'll see is the product of the sizes of the inputs here. And it will do all of that for you basically without you having to write tons of tests individually. So the actual test vectors you set up in a separate window here. So there's another file type there, which is LVVect. And you just create a new vector and then double click on this, and then you can type in the values you want for the vectors. If you don't like all of this dancing around in dialogues, you can actually open this in an external editor, in this case Excel, because these are just tab delimited files, so it can be quicker and easier just to go in and do them that way. And in fact, the test files are also just tab delimited, and you can open them as well. So you want to be a little bit careful fiddling with this manually, but you can certainly go in and change the test expected values quite easily doing that. I will very quickly. So I've got Victor the vector test there. Find everything. Oh, that's great. It's hidden. Top work. Yeah. Yes, that is also on the list. Though it's not actually completely unique. Some of the others, LUnit has that as well, but it's not fully fleshed out yet. Yeah, so you can see that just quickly zipping through, it's just going through all the different possible inputs that it could get and the outputs. So yes, as Eli just mentioned, there is code coverage in here as well, which actually I should have just shown you because it was in the results. What I'll do here instead is to run all of the tests. This will give us an overview of the 3 different tests that are set up in this project. This will take a moment to run, unfortunately. Possibly. Yeah. I would not be super surprised, it may well be. It is probably the oldest, or up there with JKI, it's probably similar.
Yeah.
I'm not sure which one's older, but they're pretty.
We came out with it right after the JKI tester, because I remember being like, what? We wouldn't have worked on this
if you'd known, yeah.
Jen, tell us this.
So communication is key, yeah. Okay, so let's run all of the tests. So our test results are in here. We can expand the tree, and it will tell you where things have failed. So this one here, we had an expected value of 3333 and only got a 3. Everything else was good. There were no errors in the tests, and code coverage, as Eli mentioned. So it will just enlarge that, tell you how much of each VI was actually covered by a test, which can be useful to know. In this case, Victor, the test vector, was super easy, and that was completely covered. And some of these much less so. A lot of the reason for this low level of coverage is probably there's an error case in here that didn't get exercised at all. That's something I will touch in a moment. And also lets you know if there are VIs in the project that haven't got any tests against them. That's also useful information to have, so you know that you've got more work to do still in developing those. One other thing too, because this is a first-party tool, the reporting setup for this actually lives in the project properties, which I'm now blanking on where they live. That one. So here, so you can set up both XML output, which is sort of suitable for CI/CD applications, or HTML or plain text reports. And in fact, they're on the desktop here, so that's the. Sorry, what's up? Yeah, right. So that's just the XML dump of the results of all of the tests there. Okay. All right. So the newest of all the ones I'm going to have a quick look at here is called LUnit from Astemes. That's another XUnit style one, and it's actually written to be quite similar to JKI VI tester in concept. So it has setup and teardown in the same way. It has a template VI in the same way, just to make that easy. It's also class-based, but this one's a bit more aggressively object-oriented than VI tester is. So all the basic testing you can certainly do without knowing too much about it, but there's a whole bunch of add-ons for things like mocks and other stuff that you need to get in amongst the OO design a little bit to really use effectively. So a bit of a sidetrack in this one. So the VI we're trying to test here is a multi-tone detector, so it's trying to look at a waveform, and it's looking for 4 tones all up, but it turns out the waveform that we're looking at here is rather boring and sinusoid looking, and that's because that's generated using a demo DAC device rather than a real device. So it's in the setup here. We've got a a slightly modified example VI that I've just used, using DACMX to generate the waveform. And that's unfortunately completely useless for unit testing with, because the waveform is not the right form for what the VI actually expects, the one that's under test. So what we need to do is expand on. Shit, what are you shouting at me for? That's because this is open. There we go. I can't edit that while the thing is open. So yes, you have to close the runner in order to, sorry, I'm trying to do too many things, talk and do stuff at the same time. So this is almost the same as the other, except that what I've done is wrap the DACMX calls into a driver. So we take all the config stuff and just pop that into a single VI. Similarly, take all the acquire stuff, pop that into VI and the cleanup stuff. So what that does is it gives us a nice, slightly higher level API to work with for the DAC stuff. And this VI is actually a drop-in replacement for the existing one, because the DAC driver class here has an input you could use to pass in an instance, but it will default to just the DAC driver based on the value in the control there. So we don't actually need to wire that up. That's an optional input. So we could drop this in place of the original VI and not have to change anything in the calling code. But what that opens us up to be able to do next is to do this, which is to create a subclass of our new DAC driver that we've created. It is actually a test double. So what that does, it has the same API as this is the actual driver here. This is the test double, so it has exactly the same API. But what it does, rather than actually talking to real hardware, the configure just takes some of the arguments that are passed in and stores them away inside of the class. And the acquire generates a synthetic waveform instead, which is more in keeping with what we'd expect to have when we're running against the real hardware. So that's got 4 different frequencies here, 100, 200, 300, 400. So now if we run the test the second time using this, I've now changed the setup so that it's using this test double and passing into the optional input into the DAC VI. So that's now using a simulated driver rather than a real one, and we just keep a record of the DAC driver so we can delete it during the shutdown, teardown at the end. I should have kept that up actually. I want to look at it. Just run that again. They now all pass because we've now got a far more interesting looking waveform that's more like what the VI was written to expect, and it's been able to pull out all of the 4 frequencies it was expecting. And there are 4 separate tests because we've done them one at a time here. So the first frequency, and then there's separate tests for each of the others. So LUnit's main claim to fame is to be fast. That's its job in life, is to be quick. So in order to do that, it can do a couple of things. It can run tests in parallel if they're able to. You probably may not be able to tell running the short list of tests, but any tests that have already passed, if you just hit run, any tests that have already passed, it will skip, and it will only run ones that have failed. So it'll concentrate on ones that you still need to work on. And you can, as I've shown up here, it has ignored dash tests. So this test here that has an underscore at the front of it, if you run that, that will not get run at all. So you can have sort of slow tests or tests that you don't want to run all of the time in your test case and just disable them and not use them all of the time. And that enables your main unit testing process to be faster. You're right. And
you're saying if the test is previously passed.
Yep, sorry, I'll bring that up again. Yeah, so if it's previously passed, if you just click on test, it won't actually run that case again.
What if the code has changed?
I'm not sure.
Like in other words, the whole point is like, yeah, it worked before, but I've went in there and deleted everything.
If you did, you can just force it to run again by holding down shift, and it will run all of them.
Okay. So it doesn't like modulate that based on whether or not the VI under test has been changed.
We can find out. So yes, it does run it.
Okay, so it knows.
It knows. It must have known it was changed, and it's run it again. So
smart.
So it is clever. Good to know. Good question.
That was a planted question.
You keep me on my toes. And then it would have just run that single case on its own that time. Okay, so that's LUnit. So yeah, LUnit's quite new and is in very active development at the moment, and has already a few extra expansions available for it, not for test mocks and things like that. So a test mock is just very similar to the test doubler that I've created there, and you can obviously just make up your own, but it's not bad practice to use a template or framework for that just to make them more uniform, because it's very easy to just go off and make them all completely different for each one. All right, and the last one we're going to have a look at here is Caraya, which is another unit testing framework from JKI, which seems a little odd, but this one is quite different in style to the other ones. It's what's called an assertion framework. So these are just the same things as you would use in a unit test, but running without any tests or anything like that. So this first one here has failed, and because I have automatic error handling turned on and turned on in the project, it throws up an assertion. So you can actually scatter these through your code, sort of outside of being unit tests, and just check things that should definitely be true, just to catch corner cases in your code. So things that you would log usually, but if you might want them to shout at you if something has gone terribly wrong in your code while you're testing it, if it's a big application, you might want a warning, other than going back and having a look at the code, the error log later, and discovering that there was a problem. This will actually jump up and shout at you if something has been misconfigured and isn't right. So yeah, so that's the assertion side of things, and the actual tests. In this case, I've got the tests are actually living in with the class that they go with. So this is what a Caraya test looks like. Caraya is quite freeform. It doesn't impose any sort of structure on you. You don't have to use setup and teardown if you don't want to. You don't have to do much of anything if you don't want to. The only things we have here are just the assertions, which are exactly the same as the ones in the other example, and a defined test step, which just gives it a name. So if we just run this, it'll give us a result list and tell us that all the things have passed. So this is a slightly more fully featured test. So this sort of is doing many tests in one VI. So this is the sort of thing you might get if you've been sort of lashing code together in a test VI, and then you can sort of take that and make it into a unit test after the fact, rather than having to go back and copy and paste all of the playing around code you've been using to develop your actual code from. So yeah, this is doing more thorough testing than some of the other examples I've shown you before. So it actually checks to see if things fail, if they don't have inputs, and check that the correct error messages are being generated first before checking the happy path. So it's important to remember that it's all good to check that you're getting the right results when you give it the right data, but you also need to check that it does same things when you give it either invalid data or errors are generated internally, and make sure all of that is working correctly as well. So it runs a single test, and there's also a runner here. So it basically describes the path of the VI and runs all of the tests that are inside of that. So that's now run all of these test VIs that are in this folder. And you can dump out XML from this as well. So this toolkit doesn't do much in the way of reporting out of the box, just like it is. There is a whole bunch of VIs in the toolkit though. So have a look at the, which one? Here we go. So you can see the basic API for it is very basic. So you define a test, have an assertion, and run tests, and that's all you need to know to do basic tests. But there is a whole bunch of other stuff under the hood here. So if you want to actually set up proper automated reporting and XML output and all that sort of stuff, there's a lot of tools in here for doing that, but you don't need to know about it if you don't need it. So in terms of barrier to entry, this is probably one of the easiest ones to get up and running with. Yes, so if you, oh, that's the wrong one. Where am I going? Sorry. Yes, there is a tools, Caraya, run all the tests, which will go and do that same thing that I just did. Yeah, so that's failed one.
So the thing is that when you get this,
that's why.
When you get that, it tells you that you have a broken test.
Hmm.
Where in the other one, you can determine what you want to test.
Yes.
But I always forget, so I run that.
Yeah.
So both Caraya and VI Tester I know are both from JKI. Is it your perception or understanding that they just serve different use cases, or is Caraya conceived to replace the?
Yeah, they definitely have different tests. They're different utilities, so yeah, they definitely work quite differently. Looking in the repo, there doesn't seem to be a lot of action on VI Tester for a long time. There hasn't been any commits to it for quite a few years, but it's pretty stable and it works fine. So maybe it's just fine like it is and it doesn't need a lot of work. So
Why did they make Caraya?
yeah, it's much lighter and simpler than, like, you don't have any classes, you just have a couple of VIs you drop in, and some of this example code that I had is actually real tests. So basically I was working out how to do the code that I wanted to do, and I sort of just strung a whole bunch of functions together and then dropped in tests to check that the right values, and it sort of became a unit test. So often when I'm exploring, like talking to a network endpoint or doing something like that, you'll just have a stream of VIs, or you'll just chain them all together and just fiddle with it until it's working, and then you can sort of condense that into a unit test without having to do a whole lot of rework to copy and paste it into an actual unit test framework, I guess. And it does, Caraya likes to do trees of things as well. This is one of the examples that comes with it. So the outside case has a test integer dictionary, then both of these VIs are called, and they have their own test names inside, and then they have multiple tests, and they should come out in the end as a tree. That tends to be how the results are reported. So yeah, so it's a little bit different structured to the strict test one number at a time sort of style for more formal unit testing.
Do the Caraya VIs typically get melded into the actual source, or that's all harnessed?
This is test only code. You can use them as assertions in your actual application, and then in the executable they won't do anything because the runtime error handling doesn't do anything. So they work like real assertions in other languages like C, where you put them in and they pop up if you're running in a debugger. And actually, like, they're like a hard breakpoint of sorts in the code. So they'll stop if whatever statement they've made about what the value should be is wrong. They'll stop.
That dialog will pop up in a no.
And not in executable, in
Not-
debug.
Yeah, only in debug, and only if you've because of the way LabVIEW does error handling. Where was I? No, actually, that's not.
That's pretty cool.
It is, yes. No, I've forgotten where my example of assertions has gone. It's outside the class, that's why.
You're going to tell us which one we should all use after this, right?
No, I'm not actually. In fact, I'm going to duck that one completely. Yes, so this VI has, in its properties, has something in here. Yeah, automatic error handling turned on. Without that, these VIs do nothing. But with that turned on, or with it turned on in the project, if any of these assertions are wrong, it will actually throw up an error dialog straight away.
I wonder, you know, the new feature in 25Q3, there's now another option
Oh, excellent.
where you, instead of having automatic error handling, you can choose to log it to disk.
Okay,
So I wonder
if that would work.
what that does. I don't know.
I know. To try it and find out.
The beta is live right now.
Got a comment on that as well. It's really useful for putting in for loops and having auto-indexed inputs and for your test cases, and then your expected results, and you can easily automate it with very little code.
What I'd really love though, Eli, is can we get Nigel to just auto-generate those VIs for me?
If it was that easy.
Come on, Fab, surely.
Nigel will just make sure you never have bugs in your code.
That would be lovely. Okay, so that's the demo portion. Then we're going to go back into slides real briefly. So what's good about unit testing? That gives you confidence that your code does what you expect it to do in several different circumstances. So not just the one you happen to have manually tested recently. It gives you regression checks. So if your code has passed tests and you change something and it stops working, you'll find out immediately rather than discovering it later down the track when you're doing integration tests or more involved testing. Hopefully encourages good design by decoupling your code and actually making sure you have APIs between different modules of the code. So there are specific points that you should be talking to, hopefully high-level APIs and not just diving into whatever VI seems convenient. It acts as executable documentation. So if you have a really thorough unit test set up for a module, it should exercise basically everything that module can do and demonstrate what things cause errors and what errors you should expect if you've misconfigured various parts of it. What was I going to say? Something else? Never mind. So, oh yes, it sort of shows if you need to stand up a lot of other stuff to make this module work, it exposes that, which can be a little bit uncomfortable. So if you've got lots of dependencies in this module, you'll have to set all of those up for your test cases. And the level of pain you feel in creating the tests sort of indicates that maybe your design isn't as great as you think it is to start off with. So it's an encouragement to fix that, which I think is maybe one of the reasons why people avoid unit testing, because it's not great having your face rubbed in the fact that your design is probably not as good as you think it is. So It's not the architect. Yeah, the architecture is fine. It's the unit test's fault. Yes, it encourages refactoring. So if you have a nice API, anything on the outside shouldn't change. You should be able to fiddle with the inside to your heart's content. And if it passes all the tests, then whatever you've done is good. So you can optimize things, make it nice on the inside. Because they're automated, I've skipped the thing. Yeah, fixing bugs earlier is cheaper, as I've said, and I've skipped past the thing. And yeah, so the fact that the tests are automated means that once you've gone to the effort of creating them, running them again is effectively free. So there's no reason not to just run them really frequently compared to if you're manually testing stuff. There's overhead cost in setting everything up and running them more than once. So you may as well automate it and save yourself some time down the track. So it does require a bit more effort up front, but in the long run, I think it's probably worthwhile. What's not great about unit testing? Extra work. It is more work to write more code. Ideally, it should be real simple though. So most of your tests should be quite straightforward to write. They're quite simple code. It shouldn't take you too much time. You can copy and paste a lot of stuff and just change the expected values and the value you're looking at. But yeah, versus manually testing things, you are actually saving yourself work in the long run. It just doesn't feel it at the time when you're writing the unit tests. It can be a lot of code, potentially. You may have lots of tests. Writing testable code can be a bit difficult. It can force you to re-architect things sometimes in order to make things testable, and some stuff just is really, really hard to test. Tests will break from time to time. If you do things that change the API around a module, it will break a bunch of tests, and there's not very much you can do about that, but it validates any manual testing you've done if you've done manual testing before, and at least some of your unit tests will still run, so you haven't lost everything. This may seem a little counterintuitive, but don't write too many tests. So you want to write just enough tests to cover all of the expected behavior of the unit, but don't overspecify what the internals are doing, because it will make refactoring difficult later. And if you break something, you'll be rewriting more of the tests. So test at the highest level that you can. So build a higher level API and test there. And if you do have to use a test double, put that at the very lowest level you can. So say you're doing an instrument driver, try and get in at the read bytes from the serial port, write bytes to the serial port sort of level. So everything else in the stack is covered by the tests. So yeah, so like with the LUnit example, I created a wrapper API around DACMX. So rather than talking directly to it, we have a higher level API, and that frees you up to use test doubles. Also, if you decide you want to use a different set of hardware for some reason, you can swap in a new class with different hardware drivers much more easily if they're at a more abstract, higher level. Some of your lower level tests might end up being scaffolding that you remove later if you start out writing low level tests for your module and it grows more high level API later on. You might end up with high level tests that are duplicating what the low tests are doing, and you feel free to go back and remove the tests at the lower levels if you don't need them anymore. If you really think you might need them for debugging, you can disable them. There's a couple of ways of doing that depending what framework you're using. They just don't double up effort. Yeah, and some unit testing is better than no unit testing. Absolutely start out doing the easy stuff first. It wasn't so much deliberate, but all the examples I showed you are network protocol parsing things that just sort of fell out from code I've been unit testing because it's easy to test. You've just got bytes in and data out, so there's no real dependency on anything else. There's no hardware involved. Yeah, complicated calculations, protocol parsers, complex code that's likely to get accidentally broken. Code you've just found a bug in is a great time to write a unit test. Write the test first, show that it doesn't pass, and then fix it, and then run the test again, show that it does pass. Your test suite will grow over time, so don't expect to write all the tests the first day you start testing a module. They will grow as you go and develop it. You may need to go in and prune out old tests. You don't have to have 100% coverage. It's aspirational. It's nice to try and cover as much of it as you can, but there are some things you just can't test. You still have all the other types of testing to fall back on. Integration testing still exists, and your final test will still be there. You're just trying to cut out the amount of, or try and reduce the amount of work involved in doing them. You have version control if you need to get stuff back. In terms of, yeah, some code just cannot be unit tested, or the amount of effort is too much. Some tests are more trouble than they're worth. So you've got to, yeah, have a think about whether it is worthwhile completely architecting a section of your application to make it testable. Yeah, so obviously long-term projects get more benefit than short-term ones. So if you're going to be working, developing on the same code base for years, and other people are as well, then you'll get more bang for buck out of putting in the time and effort to generate the unit tests. One other thing, it's actually useful for learning an application as well. If you've got the modules are isolated by the unit tests, you can go in and learn how a module works in isolation apart from the application, rather than trying to see what it does with all of the noise of the whole application going on behind it. So it can help with understanding complex applications as well. And that is it. Have any other questions? Oh, we have Neil. We have several.
Thank you. Okay, thanks for sharing. So,
Yep.
One question is that I know in the field there's some other unit test tools that also provide the coverage report. But here in the tools you just presented, the UTF is the only one can provide the coverage report, right?
Oh, actually, yeah. So I did sort of skip over some of it in the interest of going fast, but yeah. So Caraya doesn't, I don't think, generate a report. This does. Good point. Thank you.
Yeah, because some customers are really care about the coverage, so
Yes, so you do want to record the results, or depending, if you're doing continuous integration, definitely you want to record the results. So yes, so LUnit. Thank you. Thank you. All right. So yes, LUnit under tools has a reporting set up here, so you can have a text report or an XML report. They're going onto the.
Yeah, I mean the coverage report, the coverage of your unit test code.
Coverage.
Oh, coverage. Beg your pardon. Yes. So yeah, so this also has coverage. I'm a bit reticent to actually open it because it'll launch through all of the VIs that are in this project, which is a whole bunch of junk as well as actual stuff I've been showing you. So it will choke on it. But I'll attempt it and we'll see what happens. I'll just get it to ignore a couple of things. So yes, this does do coverage reports as well. They're a little bit limited. It does need to have debugging turned on for all of the VIs that you want coverage information on. So it can't look at VIs that don't have debugging turned on. I'm not sure if that is also true of NI's tool. It doesn't say anything about that.
So I know to implement our coverage, you may know this, but
Implement our coverage. There's a private VI server method we put in. I think
Okay.
it's. I don't know if it's a scripting method or a super secret. I know. Super secret. Okay, but super secret isn't so super secret. So yeah, I mean, if somebody really needs it, they could also access that method from VI server. I want to look it up. I don't remember.
Some customers also asked me about the password of our unit test framework VIs.
Yeah, so UTF
share.
definitely has it. VI Tester doesn't, Caraya doesn't, but LUnit does, but it's not quite there yet. They're still being worked on.
I have give some like workaround to achieve its functions. And another question is that, so what are in your customers, which like unit test tools are used like the most?
Like no one else uses unit testing tools except me on my code. So
Okay.
So I use VI Tester a fair bit. I've used Caraya a bit as well, obviously, because all of the examples I've shown you are actually real unit tests from production code. I didn't write any of these for the demo there. I've taken stuff out to simplify things a little bit, but that's all real production code. So yes, I've used Caraya and VI Tester a fair bit. LUnit looks really nice. I'm a bit tempted to have a go at using that as well. Unit test framework, because I do class like OOP development a fair bit, doesn't really fit the way I use LabVIEW so good, unfortunately. So yeah, so that is supposed to, it's turned on. That's what we have to do. We have to press go. That's why it's not doing anything. Waiting patiently for something to happen. It's not doing it. Yeah, so it will be faster than it just appeared, but it will take a moment to try and load in everything.
do you select that checkbox?
Be a good idea. But I think, oh, there we go. No. Or maybe we should leave it turned on actually if it's hiding stuff. So yes, I just need to ignore all these. I'm going to open up, for some reason, part of the DQMH, which I think I don't have installed. Yeah, I think.
While we wait.
Yep.
I'll ask.
Neil's got a question there.
Yes, Neil. Yep.
Maybe not so much as a question, but just certainly a bit of advice from a past life where verification was front and center of things we did.
Okay.
Unit testing is great and it has a lot of advantages and different applications like this, but I would recommend never write a unit test if you don't have a written requirement to do so. So every unit test needs to be traceable to something that you're trying to prove. And if you don't have a written requirement, then unit tests turn out to just be a lot of work that you do to prove that you wrote your VI correctly and it does sort of what you want it to do. But
Well, yeah,
it really needs to be purpose driven. Otherwise, you can get into a really, really kind of can of worms, and you spend more time writing unit tests than you did developing your code. So that's just one advice from past experience. With the documentation that comes up in the reporting, you need to find a way to trace that also to your requirements. You need to have that level of traceability, either through links. In the old unit test framework, you could comment in there, and those references to requirement identification numbers and stuff would track through. I don't know necessarily if these do the same, but
no, I think
that's definitely advice from being burned many times on this before,
okay.
And developing a whole process for this in a past company.
It's sort of not the point of unit tests to be traceable to anything in particular. They are just to prove that your code does what you think it should do.
Yeah, I disagree a little bit on that. They're there as part of your verification protocol. You can use them for self-checking, but ultimately they're there to prove that your code is working to its requirements.
Yeah.
That depends, right? If you are working for someone that cares about requirements, most of my customers don't even know what they want. So,
Well, that's right.
so it would be nice if we had requirements. But one of the things that I wanted to mention, this was focusing a lot on proving that your code works. One use that I have for unit tests now is also as an architect, especially when you're using classes, for example. If there are certain things that you're expecting your children to do, you can have your unit tests have a factory pattern that detect all the classes on your project and then can verify that you did things that you're expecting from the developers to do. It can be as simple as if there's a name requirement on all the new classes and you have documented that somewhere, but the new developer is not going to know, the unit test will remind them, right? It's like, oh, this is expecting the class to start with the name test. So if it doesn't have that name, it's not going to be recognized by whatever. And I'm just using a silly example, but you can get the idea of things that you know you're expecting and you know how to do it, but your developers may not know it. So you want that when the unit tests run, they will be notified that they forgot to do a step A or B on one of the BIs. So.
And the XML parser in particular, I'm actually actively using that in development right now to develop an XML parser. Those tests are to check that the code I've written actually does what I think it does. And the code that's inside of the parser at the moment is terrible, but it does kind of work. And I'm going back in to rebuild it, and I want to check that it doesn't break when I do so. So the quickest and easiest way of doing that is just to run the tests again. So I could manually go through and check all of the 60-odd values that get pulled out, but that seems awful tedious. So yeah, I mean, you can do it because you have to, but I mean, like I said, you don't have to test everything. Just test the stuff where it makes sense. I mean, 90% of my code isn't unit tested, but the network protocol stuff absolutely is, because it's easier to do it that way than do it manually.
Yeah, I'd like to give a thumbs up for the Caraya, because for me, what's important is to get them created, but as quickly as possible, where I'm clicking through lots of menus and setting up extra VIs is so much extra effort. But if I'm Caraya, I can string a whole heap of them together, whole lots of tests, get a lot of stuff done, and with minimum effort. And I've had been developing APIs that had hundreds of VIs behind them, and I want to test them. So but there's only small differences between them, so I can actually just copy and paste, change one little thing, copy and paste, stream them together. Yeah. And that's how I use it. Or the other thing that I use it for is if I had a large setup, something really complicated, like the test requires a TCP server. So you have to initialize a TCP server as part of your setup. You don't want to do that every single time you're running a test. So you'd actually set it up once, run through all your tests to use that TCP server, and then tear it down.
Yeah. Well, there's actually another layer that I didn't go into with VI tester, and I think some of the other ones, probably LUnit as well. There's a test suite layer, which is like setup code that gets run once, and then you run test setup, test teardown, and then there's a suite level, shut everything down. So you can do a whole swathe of tests with a single setup for something that's expensive at the start as well.
Definitely, if you have never done it, the one that is the lowest barrier entry is Caraya. Because it's like he said, you just put 2 VIs and you have a unit test. So I would suggest if you have never done it and you are tempted to do it, start with the Caraya. And then if you are a heavily OO, then you want to look into the other ones. But Caraya is a good low-level entry. Another, there's some presentations, they're probably outdated now. I did one, and then James McNally had a VTech package that you can still download. And it has 2 templates, one for testing things with events, and the other one to test using the method given, when, then. And it's just a simple sequence, but that helps you set the mind when this happens. Now, given this set of circumstances, when I run this VI, I expect this result. And that makes it really easy when things fail, because you have a story of what is it that you're testing. So that's another one to look at.
I use the LUnit, and I find it's really powerful. And I also use DQMH. One thing that I found that motivates me to create unit tests is automation. So I took it upon myself to create an automated tool that goes through and creates unit tests for all the DQMH requests and broadcasts in one shot. So you just click a button and it just creates all the unit tests and wraps everything. So I challenge other framework developers to who have scripting magic, know how to do scripting, to be able to build that into the framework itself. So whatever framework you're using, you have the tools to create the unit tests, and that again makes it a lot easier for you to do that. So I just wanted to mention that we have everyone here who knows how to do the frameworks to be able to do that. So that would be helpful. I haven't shown you, but I've augmented it. So
Can we?
Right.
Can we include that in DQH, please, Michael?
I can show you. Yeah, sure.
See that tomorrow, maybe, in the advanced workshop. Any further questions, or should we end it there? All right, let's leave it there. Thanks very much, Brett Percy.
Good.